This video is for pre-calculus / trigonometry homework 101. And I want to remind you before we get going with this, make sure you have your green sheet out. We're going to be using our solving trig equations rules on this, just a quick reminder. And this is on your homework sheet too. So remember, don't put your negatives in your TI. I'm going to remind you as we go through this. Check your different quadrants. Smile if you only have one trig function. Look for common factors. Use our oldest trick in the book, the sine over cosine equals tangent. And smile if you only have one angle to solve for. So right away, I like to call these the sum and difference identities. So we're basically combining everything that we have learned up to this point. We're not using like our double or half angle stuff on these, but we'll be doing that in the future. Today we're just doing a little bit of review and combining things that we've learned. So let's get into this. First thing we need to do, we see a sine squared here. Remember, this is in degrees, so I suppose the first thing you really need to do is change your calculator to degree mode if you have not already. Once you do that, we need to take the square root of both sides of this so that we get this sine by itself. I guess we don't want it squared. So I'm just going to recopy this down with our plus or minus square root over here. Of course, if you write this as 3 over the square root of 22, that's fine. We're just going to be plugging this in our calculator, however you'd like to write that. And so when we get to this point, we need to figure out where our sine angle is going to be. And since this is plus or minus, we are going to have an angle in each one of our quadrants. Hopefully your angles are a little straighter than mine over there. But we just need to know that, yeah, we're going to be in all 4 quadrants on this guy here. Okay, all the way around. So, next thing, inverse sine. So a second sine of the square root. Remember, don't put that negative in your calculator. We just want the square root of 9 over 22. And we're going to round. So when we do that, we'll end up with this. Theta plus 82 degrees equals 39.8 degrees is what you should get right there. Now, since we have an angle in every quadrant, we need to take 180 minus 39.8. You should get 140.2 degrees. 180 plus 39.8 is 219.8 degrees. 360 minus 39.8 is 320.2 degrees. Now I want to peek up at something here. To solve for theta, we have to subtract 82 degrees. If we look at this very first angle, subtract 82, we are going to get a negative answer for our theta. 39.8 minus 82 is negative 42.2 degrees, and we do not want that. So we're actually going to add one more angle measure down here because we don't want that first answer. So we'll go 360 plus 39.8 to get 399.8 degrees. So we're going to actually use these 4 angles then when we're solving for theta. So 140.2 minus 82, 58.2 degrees. 219.8 minus 82, 137.8 degrees. 320.2 minus 82 is 238.2 degrees, and 399.8 minus 82 is 317.8 degrees. And these are going to be our answers right there for theta between 0 and 360. And that's why we know we can't have that negative one, is because of that rule up there. Let's look at the next one. All right, we have another degree one here. This time we have cotangent, okay? So wouldn't cotangent be the same as tangent of something? We just have to flip it. We need to write this as tangent. We do not actually have an inverse cotangent, right? Because it's just, we only have an inverse tangent. That's what we're going to have to apply to this. So we're going to flip this fraction over here to negative 7 over 11. It's nice that it's in fraction form. If you have a decimal, like, for example, if you had cotangent of something like theta plus 5, I don't know, plus 5 degrees equals 1.7, you would just write this as tangent of 1 over 1.7. Of course, this is going in your calculator, so, I mean, really, it doesn't matter that much what this looks like. It kind of looks like a mess. It's fine, okay? So coming back over here, we need to now take the inverse tangent of 7 over 11. Second tangent of 7 over 11. Remember, don't put that negative in your calculator. We should get theta minus 77 degrees equals 32.5 degrees. All right. And then we need to know where tangent is negative. Okay. Remember, we have our CAST. That's where these are positive, but we're looking for where it is negative. So we're going to be in the second and fourth quadrants. I'm going to switch colors here just to keep some things straight. Okay, we've got an angle there, another angle right there. So now we actually need to figure out what those angles would be. So we want theta minus 77 degrees. 180 minus 32.5 is 147.5 degrees. Okay. And then we also need one in the fourth quadrant, so we'll go 360 minus 32.5. We get 327.5 degrees. Now we need to actually solve for theta. Theta equals 147.5 plus 77, 224.5 degrees, and then 327 plus 0.5 plus 77 gives us 404.5 degrees. Now you might say, but Miss Steele, those two angles are not in our second and fourth quadrants. Yes, I know, but we're really looking at where is theta minus 77 going to be in the second and fourth quadrants, and that's what we're solving for. So don't get confused there. We might have talked about this in class before, but this is what it's going to look like. Your final answers might not look like these angles right here, but as long as this guy right here, as long as we can make him look like into those two angles, and I suppose these two right there, as long as they are matching up with those angles, that's what we're looking for, okay? Let's do one with radians, and then we're going to call it a day with these guys. Of course, if you have any questions, make sure you email me, send me a text, or we can also Zoom call if that's something you're needing to do. All right, first step, secant squared. We need to maybe turn this into a cosine squared. Cosine squared of beta minus 1.1 equals 1 over 1.456. And that is perfectly fine to write something like that. Not a huge deal, okay? Now we need to take the square root of both sides. So cosine of beta minus 1.1 equals plus or minus the square root of this fraction. This is kind of looking nasty. It's fine. We'll get it figured out. Okay, next step, make sure you turn your mode back into radian mode. Check this out. We're between 0 and 2 pi. That's what we want our answers to be in. So the inverse cosine of, remember this is our positive square roots of 1 over 1.456. And I got beta minus 1.1 equals 0.5939 radians. Okay, so where is cosine positive and negative? Well, all four quadrants. We love when things are squared because we have four angles then, right? So first angle, that's fine, 0.5939. I'd like to remind you that we've got 1.57, 3.14, 4.71. This is all on your green sheet, of course, and this is 6.28. Just so we remember, I know our angle measures in degrees are a little easier to remember at this point than radians are, but just, double check your green sheet if you're confused on that one there, okay? Anyway, let's keep going. That's our first quadrant, so we'll take 3.14 minus 0.5939 to get our second angle in the second quadrant. And this should be 2.5461. 3.14 plus 0.5939, 3.7339, and 6.28 minus 0.5939 with these reference angles here, 5.6861. And those are our 4 angles we're going to be using. We also now need to add 1.1 to each of these to get beta. So beta should equal 1.1 plus 0.5939. Of course, you're probably doing these calculations a little faster than me since you're listening to me talk while I do them. That's fine. Okay, 1.1 plus our second angle, it's going to be 3.6461. 1.1 plus our third angle is 4.8339. And 1.1 plus our fourth angle, 6.786. Make sure you're checking these, make sure I'm doing them correctly too. I'm going kind of quickly in case I mistype something, but these are our angles for beta now. And remember, it's okay if they're not in those quadrants. It looks like this is first or second, third, fourth quadrant, and then this one's going to be back in our first quadrant again. It goes 2, 3, 4. And first, just in case you're curious about that, like how does this actually work? We do end up with 4 different quadrants of angles. So there's our sum and difference identities.